Okay, here are a few more examples for those that may need a little bit more practice. So remember, we need to get this minus 35 on the right side to make space for our perfect square trinomial. So we're going to add 35 to both sides. Now we're going to make sure our a value is 1. It is not, so we're going to factor an 8 from these two terms only. We're going to make room to create a perfect square trinomial, and to find the constant to complete this perfect square trinomial, we take half of b and square it. This is going to give us positive 1. Now we added a value of 8 on the left side because this is really 8 times 1, so we have a value of 8 on the left, so we must add a value of 8 on the right. Now we're going to factor the left, and we're going to combine the right. Now we are going to take the root of our quadratic, the sine of our linear, and the root of our constant. And now we're going to solve. We're going to divide each side by 8. We're going to have x minus 1 quantity squared equals 50 over 8, which simplifies to 25 over 4. Now we're going to take the square root of both sides, and I notice that this rational expression, the numerator and denominator, are perfect squares. So we have x minus 1. Our negative root is negative 5 over 2. Our positive root is positive 5 over 2. So I just took the square root of 25 and the square root of 4. Now we're going to add 1 to both sides. So x equals. So negative 5 over 2 is really negative 2 and 1/2. So when I add 1 to that, I get negative 1 and 1/2, or 3/2. We're going to add 1 to both sides. Again, this is really 2 and 1/2, and when I add 1 to it, we get 3 and 1/2, which is also 7/2. So however you like to write it, and for graphing purposes, this is the expression that I would use. So our two roots are 3/2 and 7/2, or 1 and 1/2 and 3 and 1/2. We're going to move our minus 15 by adding 15 to both sides. We're going to make our a value 1 by factoring out the 3 from the two terms on the left only. We're going to take half of b and square it to create our perfect square trinomial. Half of 6 is 3, and 3 squared is 9. I added a value of 27, 3 times 9, so I added 27 to the left, so I must add 27 to the right. Now we're going to factor this perfect square trinomial. We're going to take the root of the quadratic, the sine of our linear, and the root of our constant quantity squared. And we're going to combine these two terms. Now we're going to solve. We're going to divide each side by 3. We're going to take the square root of both sides. We have a negative root, and 14 cannot simplify any further than what it is. So we have negative radical 14, and we have positive radical 14. We're going to solve. One root is negative 3 minus radical 14. And the other root is negative 3 plus radical 14. And again, if you needed to plot these x-intercepts, you would use a calculator to get an estimate of that rational expression. Here's one last one. We need to add 48 to both sides. We need to make our a value 1 by factoring out the 2. We need to create a perfect square trinomial by taking half of b and squaring it. That's going to give us 1. The value on the left was really 2 times 1, so we need to add 2 to both sides. We need to factor our perfect square trinomial. And now we need to solve. Take the square root of both sides. And we have x minus 1 equals negative 5, and x minus 1 equals positive 5. We're going to add 1. 1 root is negative 4. Our other x-intercept is 6. I hope this helps.